What's up guys, Kieran McAvoy here from A Clever Chimp, and on this channel we talk, learn and discuss about maths, physics and all things engineering. This video is part of our guide to engineering maths, and today we're going to be talking about the 3x3 determinant, especially understanding in a logical manner where it came from. All of that is coming right up. So we've looked at the 2x2 determinant and understood how that's come about, but I want to use this video now to actually take some time to go through the 3x3 determinant. It may take a while, this is going to be a long video, but I want to actually go through the ways in which you're not just normally taught, the main content of this video you'll never actually use, but it will help you understand why it is you get taught the other methods. Like they're just ways of remembering how to actually get to this end result. So let's get cracking. So I've got our generic matrix here. I've got a generic 3x3 matrix here. I've got the letters are defining the rows, and the subscript of each letter defines which column it's in. Okay? Now, when we're going to look at finding the determinant of this matrix, I think it's best to sort of think about why we're going to be looking for a determinant in the first place. And one of the main reasons that I've talked about in my other videos is that we're looking to see the solutions of simultaneous equations. We're looking to see certain solutions of simultaneous equations. So what we'll do is we'll just pretend that we're setting up another generic simultaneous equation scenario where it's just going to equal L M N here on the left, here on the right. Sorry. So we have our matrix here now, and we have the simultaneous equation setup, matrix algebra setup, right? So similarly, how we found the determinant of a 2x2 matrix, we basically solved the simultaneous equations in the generic form, and we were met with AD minus BC multiplied by Y is equal to whatever it is on the other side. That's what we were met with. So let's just go down that same route here. Let's just try and solve this simultaneous equations question. One important thing though to say before we start is that, as with all determinants, they're a unique attribute to the matrix itself. Okay, so what I don't want to do is I don't want to waste an awful lot of time creating an augmented matrix and worrying about the answers L, M, N over here. I kind of just want to have the matrix by itself so that we can start doing Gaussian elimination just on the matrix and see what it comes out to be. So here we have our matrix just by itself. Okay, so what we're going to do is we're going to do the same thing that we've done with Gaussian elimination in the past. We're going to aim to get B1, C1 and C2 all to be 0, okay? And so that this video doesn't run on longer than it has to, I'm going to be using the exact same method as what I described in the Gaussian elimination video. So if you do feel a little bit turbulent here and you're not really sure what's going on, then do just go and check that out, because I'm going to be skipping through this a little bit more in terms of editing than going through it step by step. Okay, so first off, I want to get rid of B1. So we're gonna make the second row, and that's going to go to second row minus B1 over A1 times the first row. Okay, so that's our row there, and for the third row, I'm going to have the same situation. Third row is going to go to minus C1 over A1 times row 1. So here we have our new second row, and our new third row from the Gaussian elimination. We're going to just put them into the matrix now and write out a new matrix that we can then do the next step of Gaussian elimination and focus on eliminating element C2. So here we have our new matrix with the B1 and C1 made to zeros and everything else looking good. Right, so next up we need to be getting rid of this element here, the where originally C2 was. So let's get cracking with that then. So row 3 is going to be row 3 minus. And we're going to be minusing because we want this term to be minused away and this to cancel with the denominator. So we're going to be minusing C2 minus, and I'm going to make C1A2 all over A1, C1A2 all over A1, and that is all over B2 minus B1 A2 all over A1. Okay, and that is multiplied by row 2. Okay, we have our new method that we need to follow, and it's gonna get pretty hairy. Like, you can already tell that there are going to be a lot of terms floating around the place, so we're going to have to be real super careful of actually taking it slow and making sure that we actually, like, get it all right. Okay, so and remember, if at any point you feel like you want to take it away, go ahead and do so. Pause the video and just crack on yourself. All right, so we have the element itself, C3 minus C1 over A1 A3. So we're going to be minusing all this business here, so that's C2 minus C1 A2 all over A1 all over B2 minus B1 A1 all over, B1 A2 all over A1. See, I almost went wrong already. Like, it's just like, immediately when you're just seeing all of these numbers, it can just get overwhelmed. But it's all about just taking it slow. Just take it slow. So, and we're multiplying that by the element in row 2. So then we have that. I'm going to just do brackets so that it's obvious. We've got B3 minus B1 over A1 A3. All right. Whew. Okay, so that's where we're at, and then now we can just work on that. Now this is where we're at. We've got this, and now it's just a matter of rearranging it and making it look pretty. Because right now, that's arguably the determinant. But let's try and get it so that it looks something like what we would want. So first things first, I'll rewrite this bit out. So we've got C3 minus C1 over A1 times A3, and we're minusing all of this. But what I'm going to do is I'm going to multiply this with this and then just have it all on top. So it's as if I've just brought it up and it's just two brackets. Okay, so the first term is going to be C2 times B3. So that's just going to be C2 times B3. Second term, C2 times minus B1 A3 over A1. So that's going to be minus C2 B1 A3 all over A1. Okay, and then we're going to minus this. We're going to multiply this term and this term. So we've got minus C1A1 B3, C1A1 B3. Oh, sorry, C1A2 B3 all over A1. Wow. Okay, and then finally we've got this one here. We've got two minuses, so this is going to be plus This is going to be plus C1 A2 B1 A3, and that's C1 A2 B1 A3. Okay, so double check that's right, yeah. But we've also got A1 and A1 here, so now it's going to be over A1 squared instead of just A1, okay? And all of that is over B2 minus B1 A2 all over A1. Delicious. Absolutely delicious. We are getting places. We are definitely getting places. Okay, so to make life easier for ourselves, to get rid of these well, the majority of these on the top, these A1s, sorry, on the top, I'm going to multiply just this fraction here, just this fraction, both top and bottom by A1, because again, with that, it's not changing anything with the expression, because you're not actually, you're not changing the fraction at all, you're just multiplying both in top and bottom by A1, so it's absolutely fine, that won't change anything to do with the expression. So we've got C3 minus C1 over A1, A3, minus, now if we're multiplying this by A1, we've got A1, C2, B3, minus, A1s will cancel when I multiply these terms, so that's C2, B1, A3, minus C1, A2, B3, and then only one of the so this will go from a power of 2 to a power of 1, so then we'll have plus C1 A2 that looks like a 9, I apologize, A2 B1 A3 all over A1, all over, multiplying the bottom by A1, we've got A1 B2 minus B1 A2. Fantastic! Right, let's keep going. So now what I'm going to do is I'm going to just multiply everything by this denominator here, right? So we've got, I'm going to probably need some room here, so I'm going to just start writing over here. We've got C3 minus C1 A3 all over A1, and I'm going to put that in brackets, and we're going to bring up A1 B2 minus B1 A2, and then we're going to minus all this business up here, okay? So I'm just going to quickly copy that down. So there, we're getting very, very close now. We're getting very close. I've got this, after multiplying by this cancelled, and we're just left with all of this as an expression on for this part of the whole expression. So let's go ahead now and start multiplying out. Let's just start multiplying out. So we've got C3 A1 B2. We have C3 A1 B2, and then we've got C3. We got minus C3 B1 A2. Then we got C1 A3 A1 B2. So the A1s are going to cancel, so we're going to have minus C1 A3 B2, because the A1s cancel when we've multiplied those two terms together. And then we've got plus, because we've got two minuses now, we've got plus C1 A3 B1 A2, C1 A3 B1 A2 all over A1, okay? And then we have to minus, so sorry, I should have actually put all of that, in brackets, because that's actually, that used to be part of this fraction here. So we've got minus, and what I'll do now is I'll actually have it so that we're expanding this bracket out essentially after multiplying in by the minus. So we have minus A1 C2 B3, and then minus times a minus is going to be plus C2, B1, A3. And then we got plus again. We got plus C1, A2, B3. And then we got a minus and a plus, so that's minus C1, A2, B1, A3, all over A1. Yes! Alright, we are there. We are there. Right. Well, we're almost there. Very, very, very close. Right. So let's do a little bit of neatening up here. We have this. These two cancel. This term here and this term here are exactly the same. C1, A3, B1, A2. C1, A3, B1, A2, all over A1. They cancel. So that cancels with that. And we are left with these 6 terms here. We have, and I'm going to do it in a pink colour to make it the finale. I'm going to do the positive ones first. We'll go C3, A1, B2 plus C2, B1, A3 plus C1, A2, B3 minus C3, B1, A2 minus C1, A3, B2 minus A1, C2, B3. Yes! Get in! Right, that is the determinant of a 3x3 matrix. That is the determinant of a 3x3 matrix, because this right here is what would be multiplied by z to equal some number over here. Because obviously you would do all of that, you know, all of that rigmarole with the row operations to the what it equals to with the augmented matrix and all that kind of stuff. So, but regardless, you know, because that's just going to be some number that side, or, you know, whatever it's going to be. But the thing that determines the actual whether or not there's going to be solutions or not is this part right here, and this is the determinant of a 3x3 matrix. So one of the things that actually isn't talked about is what's the pattern? Why is that? Why, you know, what's with the pluses and minuses, and, you know, the fact that they're all grouped into little threes, and, you know, all of that kind of stuff. What's it about? Well, it has a very combinatorial based pattern behind it, essentially. And essentially that pattern is found because of doing what we've just done. We've done the hard work. And then if you were to do that same method on a 4x4 and do the hard work with that again, you'd get a 4x4 determinant. And then you'd start seeing patterns. You'd start seeing, like, oh well, you know, it's quite clearly a recurring pattern, and that's all maths is just noticing patterns and then writing them down as rules. That's essentially what maths is. So I do want to do a video discussing what how to remember a 3x3 determinant and what the combinatorial reasoning is behind it. So that's about it, guys. Thanks very much for watching. I hope that this has given you some sort of understanding or insight behind why it is that beautiful 3x3 determinant is what it is. If you liked the video, then do leave it a thumbs up, and remember to click that subscribe button and hit that bell icon to stay up to date with all things coming out from A Clever Chimp. Thanks very much for watching, guys. I'll see you in the next video. Bye-bye.